Hello everyone, and welcome to our video on the rules for derivatives, or at least the rules for now. So there's lots of rules, but here we're looking at some with graphing. So when graphing, or if we're looking at a graph and we want to know if there's a derivative there, it depends on three different things. So we want a smooth continuous function, like a polynomial, that would be differentiable everywhere. So a smooth continuous function would be something like that. Okay, so nice and curvy, so no sharp edges. However, some functions are not differentiable at certain points. So this we can find a slope to the tangent line anywhere. Okay, so wherever I draw it, I'm just going to do a little bit. So if I pick this point, I could find a tangent line. If I pick this point, I could find a tangent line. If I pick this point, okay, so just to exhaust it out. Okay, so we could find all sorts of tangent lines. All right, however, if there are sharp corners or if there are other things, that's these three, a function will not be differentiable at those x values. So it says a function f is not differentiable at a. They might say at x equals a, so x equals a number. If at least one of the following conditions hold, f is not continuous at a. Okay, then f has a corner or a wedge or a cusp. So that's like a V shape or like almost like a children's drawing of a bat. Okay, so they can be upside down, something like that. Okay, so those are wedges and cusps. Or if f has a vertical tangent at a. So if our graph goes vertical for a second there like that, again, we can see it right below as well, then we're not going to have a slope. So, and that's based on if you have a vertical line, let's put it here. So remember, a vertical line, still we would do rise over run to try to figure out the slope. Well, a vertical line has a slope that has a run of 0. Okay, so if it's vertical, it's not going left or right at all. And now we have to remember, well, 0 in a denominator is undefined. Okay, so that's why we wouldn't have a derivative there. Okay, however, once we have these rules and these 3 points known, it's often pretty easy to figure out where a function would not have a derivative. Okay, so on this problem, it says given the graph of y equals f of x, and they might label it like that to the side somewhere in the graph. And on this, so often things get cut off. We're going to assume, let me put these arrows, we're going to assume those keep going in their general direction. Okay, so otherwise they would need to put a big dot or an open dot to let us know it should have stopped. Okay, so given the graph of y equals f of x, find the x values where the function does not have a derivative. Okay, so we're looking at those 3 cases right there. All right, so here we go. Here we've got a cusp or a wedge. Let's say wedge / cusp. And then we just need to know the x value. Okay, so I'm going to say no derivative at x equals -3. Okay, so there's no derivative there. And then our next one, well, we see it's not continuous here at x equals 0. Okay, so this is a discontinuity or discontinuous. Okay, so not continuous here at x equals 0. Okay, so also at, I'm going to do like that, at x equals 0. And then the last one, so the vertical, so this gray line is showing there's a vertical tangent line. So this graph goes vertical for just a second there, which means, all right, well, where's this happening? It's at x equals 2. There we go. That's it. There they are. So this graph or this function does not have derivatives at those x values. Okay, so what that also means is in the blue, it means I can't draw a single tangent line. So like for instance, over here, I could draw a tangent line and it's fine. And that's the only one that I could draw. At this cusp, so it's like on a teeter-totter. So that would touch it once, but so would that. So would this one. So we have more than one option. So that means it's not a single tangent line. So that means we can't get a derivative. So there's something weird going on here. At the discontinuity, okay, so I would have a tangent line, something like this near it. I'm just gonna label it. But again, at this point, well, what's happening? Is it, which one of these is it? And then over here, I have different tangent lines. Okay, so I'm getting all sorts of different tangent lines. Again, that can't work. And then we already talked about the vertical tangent line. 0 would be in a denominator. So that means, yes, we have an undefined derivative. Okay, that's that. All right, so I think that's good. Let's keep these shorter after one of the long ones a couple videos ago. So thanks for watching, and I'll see you again next time.